Hi everybody, I hope you all are doing great. So welcome back to another video, and it's the fourth video of this series, and I hope you are enjoying the series so far. We just have to be consistent in the coming days as well, because this whole playlist is of around 50 videos, right? So one question per day, one question at a time, we'll be solving, we'll be understanding, and in the upcoming days DP will be under our belt itself, right? And all the questions we are covering are all the classical problems, so you don't have to worry about if there are any more problems after these. We are covering almost all the classical problems which are there in this topic of dynamic programming. So the question is house robber, right? So let us see what is this question. I've already liked this question, and this question is a very famous problem of linear DP, right? So let us see. You are a professional robber planning to rob houses along a street. Okay. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into the same night. Now, the thing is that there are houses and I'm a professional robber. I can rob all the houses to get the maximum profit, right? But the thing is that they have given us a constraint here that you cannot rob two adjacent houses together. You can rob houses, for example, if there are houses 1, 2, 3, 4, 5. You can rob house 1, but if you're robbing house 1, you have to skip house 2, right? It is up to you if you want to rob house 3 or maybe you want to rob house 4. So let's say I rob house 4 and then I have to skip house 4 itself, right? If I rob house 3, right? This kind of a question, you cannot rob two adjacent, houses, and then you have to, tell me what is the best profit you can make as a professional criminal. Give an integer array nums, represent the amount of money of each house. Here the array is given us representing the number of money, like the amount of money every house is having. Return the maximum amount of money you can rob tonight without alerting the police. You just have one night, so of course you can do a single pass and you have to tell me what is the best you can do without sounding any alarm, right? So let us analyze this question in more depth, and let us then try to derive if we can get some kind of recursive solution or a solution at all. So you can see here, I have drawn a test case to analyze. So these are the houses which are given to us. Here are the indexes of these houses, and here are the profits associated with every house, right? So we are a robber and we have to rob every house, right? So how can we possibly rob the best possible, you know, profit, so that we are not robbing adjacent houses, right? Yeah, if I rob this house 1, I'll not be able to rob house 10 because I cannot rob adjacent houses, right? So I will skip this house and I will rob this house, correct? If I rob this house 10, right, then I'll not be able to rob this house 2 as well, correct? If I'm robbing this house 10, not be able to rob this house 10, so this house 2. So let's skip this house 2 itself. Can I rob house 4? Yes, I can definitely rob house 4 because I've already robbed house 10 and 4 is not adjacent to this 10. But do I want to rob this house number 4? No, because if I rob this house, I'll not be able to rob this next house which is 10. We have to be as profitable as possible. Now, if I rob this house 4, I'll not be able to rob this house 10. So I will skip this house 4 as well for the hopes that I'll be robbing the next house itself. So I'll rob this next house 10. Yeah, if I would have robbed this house 4 now, I would not have been, not have been able to rob this next house. I don't know if Robin is a word or not, but okay. So 4, I'm not robbing and I'm skipping it for the, you can say greediness for robbing the next house. I'll rob the house 10. Now, if I've robbed this house 10, do I want to rob the next house 5? No, I cannot, because if I do so, alarm will go on and police will come, right? So I will simply not rob this fifth house as well, and I will move to the next house as well, right? Police will come. What is the meme about that? Okay. So 5, you can of course tell that in comment section, right? So 10 and 5, we are not robbing this house 5, correct? We are not robbing this house 10. 5. I'll simply rob this house 6 because I don't want to skip this time, because if I skip this house 6, I don't want to rob the next house, right? So you can easily see that what we are going to achieve here. If I rob this these three houses I'll be robbing ideally, right? And the ideal profit I will be able to make will be 26 itself. Is this clear to everybody? That 26 is the best profit that you can rob out of all these houses if you are not robbing adjacent houses, correct? So this is the explanation to this problem, and now let us try to see if we can get a recursive solution for this kind of problem. So let us see if we can derive some recursive relationship in the approach. Here, for example, I am standing on house 0. What is the best I can do? What is the best profit I can make if I rob house 0 and all the houses after it in one single night if I'm not robbing the adjacent houses? Zero's answer is dependent on what? If we rob this house 0, I'll not be able to rob this house 1. The next house I'll be able to rob is house 2, correct? House 2 I'll be able to rob. Okay, if I'm robbing the house, this 0 house, if we are robbing this house 0, I'll not be able to rob the just adjacent house. I'll be robbing the next to next house. And if I'm skipping this house 0, so I can definitely start my robbery from the house 1 itself. So I can start my robbery from house 1. Are you getting the point what we are trying to achieve here? If I'm robbing the house, every time I'm having two choices, either I can rob a house or I can skip a house. If I rob this house number 2, if I'm robbing this house number 2, can you simply say, can simply say that, I'll not be able to rob the next house, which is house number 3. If I'm robbing the house number 2, I'll not be able to rob the house number 3. So the next house after house number 2, if I rob the house number 2, will be the available house after 2 is 4. So I'll be able to rob the house 4, correct? Are you getting what I'm saying? Let me start it from the very beginning. Let us look at it again. So what I'm saying is that if I start from the house 0, what is the best I can do? So let's say we start from the house 0. Now from the house 0, I have two options. Either I can rob this house or I can skip this house, correct? From the house 0, I have two options. Either I can rob this house or I can skip this house. If I rob house number 0, the next house which will be available for robbery is house number 2, correct? If I skip house 0, right? So if I rob house 0, I'll not be able to skip house 1. The next house which will be available is house 2. So house 2. If I do not rob house 0, can I say I can start my robbery from the 1th house itself? Yes, definitely I can. Right. Now from the second house, I'm having two options. Either I can rob this house or I can skip this house. If I rob this house number 2, right, whatever profit I am able to make from the house number 4, that will come here. Because if I'm robbing house 2, I'll not be able to rob house 3, na? If I'm robbing house number 2, I have to see what is the best I can do if I'm starting from house number 4, right? Because adjacent houses cannot come if I'm robbing. If I'm not robbing house number 2, can I simply say that here house number 3 can simply, I can start my robbery from house number 3 itself, because I'm not robbing house number 2. This simply means that I will be able to rob the next house itself, right? So this is how recursion is looking like in this particular problem. So 4 के लिए क्या होगा यार? 4 will call, of course, robbery and not robbery. So if we do a robbery on the 4th house, just hold on to what we are trying to achieve, and then you'll be like able to understand whatever we are trying to do. So if I rob this 4th house, will I be able to rob the 5th house? No. The next house will be 6, right? So the next house I'll be able to rob is 6. If I do not rob the 4th house, I'm not robbing it. Can I simply try to start my robbery from the 5th house itself? Yes, definitely. The next house will be the next house, right? Now let us go in this direction only. If I'm standing on 6th house and I try to rob this, I think the test case is very big, but yeah, it is good. Okay, you will get the complete understanding. Although video might be long, but अच्छे से समझ आ जाएगा. That is the main point. DP we are not studying multiple times. We have to study only single time so that we remember, right? So let me bring this test case a little bit closer. Just give me a second. Okay. Now 6. If I rob the 6, you can of course increase the video speed as well as per your convenience, right? 6 के लिए क्या करेंगे यार? If I rob this house number 6, what will I do? I'll not be able to rob house number 7, right? The next to next house will be available. So I'll try to rob house number 8, but there is no house number 8 actually. Let us right now let's move forward. 6 के लिए क्या होगा? If I do not rob 6, I can start my robbery from 7 onwards. So I'll be starting my robbery from 7 onwards, right? So this is what we are trying to achieve in a recursion relationship. ध्यान से देखना यार. Now we are standing on house number 8. यार, is this a valid house? No. So what is the profit I can make if I start robbing from house number 8? I cannot make any profit. So from here, what will we return? We will return 0 because this is a base case. I'll return 0 from here because this is the base case. Correct. Now look at this house number 7. House number 7 is also having two options. If I rob this house or if I do not rob this house. If we rob house number 7 or if we do not rob house number 7. If I rob house number 7, what will I able to do? I'll be able to start my next robberies from the next house itself. Correct. I'll be able to start my robberies from the next house itself. House number 9, that is. So if I rob house number 7, I'll be able to rob the next house itself, right? So next to next house, which is house number 9. If I do not rob house number 7, I'll be able to rob the next house itself, which is house number 8. 9, you can see we have exceeded the house limits and there is no house called 9. So we'll simply return 0 from here as well. This is also base case. This is also no house which we are having. This is not a valid address. I will return 0 from here that we have robbed here. Now, 7 is having two options, as you can definitely see. 7 is having two options. Either we can rob 7. The future we are getting 0 profit, or we can not rob 7. If we rob 7, can I write this as 0 plus what is the cost of 7? 1. Right. I am robbing 7 here, right? This profit is associated with 9 onwards. And this is my own profit. I am robbing 7, 0 plus 1 or 0 if I'm not robbing 7. Definitely 0 plus 1 is better. So I will return 1 here. Now you have to get the complete understanding. By the time we reach here, you will be getting the complete understanding. ध्यान से देखो यार. This 6 we are standing on. If we are standing on 6, can I simply say that if I rob this house number 6, this is the thing I can get from house number 8 plus what is the cost of house number 6? It is 6. But if I do not rob house number 6, the best I can do from the future is 1. If I rob house number 6, this is the, I am robbing 6 and this is the future, what the future houses can do. And if I do not rob 6, this is simply the future itself, right? So what is the best answer? Of course, 6 is the best answer. I will be returning 6 itself. Now let's look at 4. 4 has got the answer for 6. 4 has to call 5 now. If we call the fifth index is having two options. Let's see what are those options. Let me, move it a little bit to the side. So let's move it here. So 5 will be calling two things. If we rob 5 or if we do not rob 5. If we rob 5 or we do not rob 5. Now, if we rob house number 5, can I simply say that if we are robbing house number 5, yes, next house I'll be able to rob is 7, right? Next house I'll be able to rob is 7. If we are not robbing house number 5, I can start my robbery from the next house itself, right? Are you able to get this logic as to why if we are robbing the house, I'm referring to next house because I cannot rob adjacent houses, right? So if I'm robbing the house number 5, I'll not be able to rob adjacent houses. Next house I'll try to rob is 7, right? Okay. Now from this 7, can we say something? Can we derive some relationship, right? So 7, you can see that we have already calculated the answer for, and here comes the DP. We have already calculated the answer for 7, right? I do not want to call 9 and 8 again, right? Because from here I'll be calling 9 and 8 if I'm trying to call a solution, right? Can I directly return from 1 from here, assuming that we are writing the memoization code? Because we have already seen in last 3 videos how memoization acts. We are not trying to recompute things. So 7, dude, like I definitely do not want to make other calls, right? Because this is 7 itself. And if this is 7, we have actually already calculated the answer for this, correct? And since I've calculated the answer for 7 already, can I simply return the answer which we have returned earlier? We returned 1 earlier, so I'll return directly 1, right? If you are not able to get what I'm trying to do here, you should of course refer the previous videos as well, and you should learn about memoization first, right? Then only this concept will be clear that we are not making any other recursion calls because we have already calculated the answer for 7. If we further call this 7, I'll be calling this 9 and 8 again, right? I don't want that. I don't want to repeat myself in the work, right? So I'll directly return 1 from here. So 5 has got 1. Have we already calculated the answer for 6? Yes, definitely we have. You can see from 6, I'll be returning 6 itself, right? So I'll be returning 6 from here because we've already calculated the answer for it. And can you simply see, that 5 I'm talking about here? 5, if we rob 5, the best I can do is what the profit I can make by 7 plus what is the profit on 5? It is 5 itself. And if I do not rob 7, if I do not rob 5, what can I do? I can simply, I'm not robbing 5, so I'm not adding this to the future, whatever is the profit I'm making in the future houses. So I'm not robbing the house number 5. The best I can do in the future houses is 6 itself. Is this clear? So what should I return? The best of these two values, 1 plus 5 and 6. The best is 6 itself. So I'll be returning 6 itself from here. Is this clear to everybody? Right. If you do want me to make the whole recursion trees always, you can definitely tell me in the comments itself, right? But I'm assuming that you have watched the previous videos and you understand the concept of memoization. Repeating stuff will just make videos much longer and you will feel demotivated to watch or to even start watching a video, right? So I'm avoiding the repetitive work, and since we have already learned about memoization, I'm already returning what we have calculated answer for already, right? So 4 we are standing on. 4, if we rob 4, the best I can do from future is 6. Plus, what is the price I can get from the 4th house? It is 10. It is 10. 6 plus 10. 10 is associated with the 4th house. I'm robbing this 4th house, so I'm able to earn the profit of 10. And this is the 6 from the house number 6 onwards, right? If I do not rob 4, I'll be able to make only 6. So what is the best? Of course, yeah. 6 plus 10 or 6? It is 16, right? I'll be getting 16 as the maximum profit and I'll be returning this itself. Not standing on this 2, what should I do? If I do rob 6, if I do rob 2, I'll be able to make 16 plus what is the house number 2? It is having 2. If I skip robbing house number 2, if I skip robbing house number 2, what can I do? The best. From house number 3 onwards, have we calculated the answer for 3? No. Let's try to see. Let's try to calculate the answer for house number 3. I'll be making the call from here. So if we rob house 3, if we do not rob house 3, if we rob house 3, if we do not rob house 3. So if we rob house number 3, I'll reach this house number 5 because I'll not be able to reach call house number 4 because police are police, right? So adjacent houses cannot be robbed, right? So next house I'll be able to rob is 5, and for 5 we have already calculated the answer. 5 always returns 6, so I'll directly return 6 from here. 3 के लिए ध्यान से देखना, 3 is not getting robbed, so the next house I can definitely try to rob because adjacent houses, like I'm not robbing third out, I'm trying to rob the next house. So what is the best I can do? It is whatever is from the 4th index itself, and you can say 4th index is returning what? 4th index is returning 16 in the return type. So from here, can I simply say 16 will be returned? 16 will be returned. So if we are robbing third house, the best I can do in future plus what is on the third out? It is 4. And if we are not robbing the third house, I'm able to do 16 as best. So best is to not rob the next house itself, like third house itself, and I'll return what? I'll return 16 itself. And now you can simply see for this case of 2, if we rob 2, I'll be able to make 18. If I do not rob 2, I'll be able to make 16. So best is robbing 2. So here I'll be getting this 18 from 2 itself as the return type. Now if we are robbing the house 0, 18 is the best 2 can do. 18 is the best house number 2 can do. And we are robbing house number 0 as well. So 18 plus 1, which is 19, right? And if I'm not robbing house number 0, right? If I'm not robbing house number 0, I'll be able to rob house number 1. Let us see how the calls of house number 1 would look like. Dhyan se dekhna. We have not already calculated the answer for house 1, so let's calculate that. So it will be calling two things, robbing and not robbing. If we rob house number 1, if I rob house number 1, I'll be able to rob the next to next house, house number 3. If I do not rob house number 1, I can start robbing from the next house itself, which is house number 2. And you can of course see that from 3 we have already calculated the answer. We return 16 when we are trying to get the answer. The best house number 3 can do, right? What is the best house number 2 can do? We are returning 18. So we'll be returning 18 from here. Now can you observe one thing? If I'm robbing house number 1, I am doing 16 plus what is the cost of house number 1 plus 10, which is 26. If I am not robbing house number 1, the best I can do is 18. So definitely the profit is in robbing house number 1. So I'll return 26 from here. And you can see what would 0 return. Would 0 would like to get robbed or not? No, because 18 plus 1, 19 I'm able to do when I'm robbing myself. and 26 I'm able to do when I'm not robbing 0th house. So we'll be returning 26 as the result. And 26, how are we achieving 26? You can see 0 is not getting robbed, 1 is getting robbed, and look at this 3. 3 के केस में क्या होता है यार? 3 is getting the best answer from not getting robbed, right? From 4th index itself, right? Now 4 is getting how? 4 is getting the best answer after getting robbed, correct? So can you see we have actually calculated the best answer, and we are ensuring that no two adjacent houses are getting robbed itself, because whenever we are trying to rob, we only get the future from the next to next house, and if we are not getting robbed, then I try to get the future from the next house itself. Now I'm not saying that if I'm trying to rob this house and I'll ask the answer for this house, it is up to this house. This house can come in this best answer or it cannot come in this best answer as well, right? It is not necessary that, if I'm calling from 2, that let's say I'm robbing 2 and I'm calling from next to next house, I'm asking that what best can you do, because I am robbing 2, I cannot rob the next house, I am asking for your best. Here it is up to this house, and it is just dependent on the people after this house, that whether this house can be included in its own answer or not, right? That's what I'm saying. Like 0, we are calling 0 itself, but is 0 getting included in its own answer? No, right? So this is what is recursion looking like for this particular problem. Let us quickly see the pseudocode for recursion, then we will directly do recursion code and memoization code as well, and then we will move forward to tabulation itself. Okay, so let us look at it in concise way. Let me write the recursive pseudocode for this problem. So integer function I'll call, and I'll pass the array, which is houses, and the ith house I'm standing on, right? Now if I becomes greater than equal to arr dot length, right, I have exceeded the array, I will return 0 from here. And if arr is in the house itself, now integer include is equal to, and integer exclude is equal to, if we are including this house, then definitely error of I is the profit associated to this house, plus what the best we can do from error of I plus 2th house, correct? Because we cannot directly rob the next house itself. Is this clear to everybody? Right, bring it a little bit here. So ARR of I, I'm including this house, I'm robbing this house, so ARR of I is the profit associated to this house, plus what the best the I plus 2th person can do. And if I want to exclude this house, can I simply say ARR of, I simply call the function here, what the best ARR of I plus 1th house can do. And in the end, I will return what? Return the max of include comma exclude. This will take care for all the adjacency, because when we are trying to include ourselves, we are not, in the future, we are not looking for inclusion. And if we are trying to exclude ourselves, I'm definitely trying to include that particular house, right? So let us write this recursion code itself and then move forward to the memoization. So we are in the code itself, and let us try to write the recursive code itself for this problem. So public int recur, I'll write a recursive function. Integer nums will be given to me as the array. Let me write AR just as the pseudocode itself, and integer ith house I'll be standing on, right? So if somehow I reach a house which is greater than equal to AR dot length, I will return 0 from here, because I cannot make any profit if I have exceeded the houses, if the house index is invalid. Else I will do what? If I am trying to include this particular house, if I am trying to include this particular house, I can simply say that if I'm trying to include this particular house, I'll say that I'll call for, of course, ARR of I, the profit for this house will be added, plus recur for ARR comma I plus 1th house will be included, right? If I am trying to exclude this house, recur for ARR of ith house will be I plus 1th house will be called here. Of course, here I have to write I plus 2, because if I'm calling, if I'm robbing this particular house, I cannot rob the next house itself. I have to rob next plus next house, right? Next house, right? So I plus 2th house, what's the best I plus 2th house can do? Plus what I can do is my inclusion profit. If I am excluding myself, then the next house, the best it can do, that is the thing. I'll return max map dot max of include comma exclude, and that will be the house itself. Return recur for nums, and I'll start from the house number 0. That will be the get me the answer for this problem itself. Let's see if it runs. So yes, it is of course accepting. Let us try to write or let us try to write our own test case as well, and then try to see if it. So I've written our test case here. Let's try to run this and see if we are getting the answer 26 itself. So yeah, we are getting the answer for 26 as well, and this is working fine. So we have to convert this recursion code to memoization code. But for recursion code, I have to take a DP array to remember the answers. How many, what will the dimensions of that array? Can you see that? We are only having a single parameter which is changing. That was the trick I talked about in the last video. So integer array DP will be of a single dimension, new integer, and the length would be, of course, it would be nums.length itself, length, correct? And let me write the memoization code as well. I'll just copy this recursion function, right? And in this recursion function, wherever I'm calling recur, I'll just name it memo, right? And of course, here also I'll be passing an integer array DP in the memoization code. DP will be passed as it is, and here also DP will be passed as it is. Now, only thing is that we have to remember the solution before returning. I can simply do something like this: DP of I is equal to math.max this. So return DP of I is equal to math.max include comma exclude. This line, this single line will handle that as well, right? That return statement as well, right? So, okay. So this has handled the remembering part. We have remembered, BERD, the answer for ith case, right? Ith house. Now, if DP of I is not equal to 0, if you have already calculated the answer for the ith house, without doing the work, just check if you have already done the calculated the answer for it. If you have already calculated, I'll simply turn DP of I here itself, right? And this would be the memoization, the time optimized memoized solution, and would work in linear time, unlike the recursion which is working in 2's power n, right? So I'll simply call return memo. I'll simply write here nums. I'll pass 0th index and I'll pass the memo array here. And let us try to run this. If it works, that would be great, right? So it is giving us an error, not memo. I have to pass DP array here. Exactly. So, all right. So let us see if it is working. Yes, it is getting accepted. And yeah. Yeah, it would get submitted as well. Okay, it is giving me time limit exceeded when we are trying to submit it. Of course, time limit exceeded. Let us see if, why is it giving time limit exceeded? 0, 0, 0, 0. Okay, so they are giving zeros in the test cases as well. So I cannot initialize the array with 0. I have to initialize with arr arrays dot fill dp with -1. If -1 is there, this means that I have not calculated the answer for it. Okay, so here what I'll do, if it is not equal to -1, then I will do the work for it. Let us use this test case and let's see now if it is running. So yeah, now it is just passing fine. Let's now try to submit the solution. It would work now in linear time itself, and it is getting accepted, right? Of course, it beats 100%. It's getting accepted because it's working in linear time. Now let us try to convert this memoization code to tabulation code, as we have done in the previous videos as well, using the trick itself. Now to simply convert the memoization code to tabulation code itself, I'll directly apply the trick itself. So instead of recursion, we are doing iteratively. So I'll create a function called public integer tabulation, and here I will have integer array arr, and integer dp only will be passed here, correct? So dp is 1d. What was the trick? We'll be starting a loop from the base cases. There is only one changing parameter, so only one loop will be there. And we are starting from the base cases. So base case is what? The last index, I can say, of the array. So I'll be starting the loop for integer I is equal to arr dot length -1. I greater than equal to 0, I minus minus. We are starting this from the base cases itself. Now, if I'm starting from the base cases itself, right? Now, as soon as I've entered this loop, the thing I have to do is I'll simply copy paste this memoization code here. Let us copy this memoization code here. I'll simply copy paste this memoization code inside this for loop itself. So this is the for loop I'm having, and this is the memoization code I've copied, right? Now, wherever I am, first of all, let us remove the memoization statement. This statement is return, right? Wherever I am returning, I have to continue, right? This test case would never occur because we are already starting in bound itself. Let me comment this for now. And wherever I am calling return, I'll continue. I can simply remove this return statement, and it would work like continue only, because after this line, the loop will go to the next iteration itself, right? So I've done that. All the return statements are removed with continue. Now wherever I'm calling the function, the memoization function, there I have to access the DP array, right? So what will I do here? I'll try to access the DP array, DP of I plus second index, DP of I plus 2th index. I'll try to access here, right? Is this clear to everybody? Here I'll try to access what? I plus 1th index. Yes, DP of I plus 1th index I'll try to access. Now there's a problem. This I plus 2 can be out of bounds, right? And similarly, this I plus 1 can also be out of bounds. So for handling these cases, I'll simply enclose them in a bracket. I'll check if I plus 2 is greater than equal to arr dot length. And if they are equal to greater than equal to arr length, I'll consider 0 to be the answer. Else I'll access that DP array itself. Here as well, if I plus 1, this is ternary operators we discussed in the last video. So enclose this in the bracket. What is the Boolean condition? If I plus 1 is greater than equal to arr dot length. If this condition is true, you should consider 0 because of this case, right? This case, whenever I is greater than equal to 0, the arr dot length, I'll simply return 0. Else, I will try to access that DP array itself, and this is the tabulation code itself. Let us now try to run the tabulation code. So, I'll simply say return tabulation arr and dp I'll pass as it is, and from here I will return dp of 0. I'll return whatever we were calling the recursion for. I will calling recursion for 0th index. I'll return that value itself. Here we are building the answer from the base case itself. Is this clear to everybody? So yes, arr is definitely not the name. I'll name it notes. Correct. Let us now try to run this code. So accepting, and let's try to submit it. It would get accepted as well. So this is the tabulation approach to solve this problem, right? This problem can be further optimized into, of course, space optimized solution as well. And now let us try to see what is the space optimized solution to this problem. Now for the space optimized solution, I'll be using two variables only, if I'm including the previous house or if I'm excluding the previous house. So let us look at this one index. Now if I'm trying to get the answer for this 0th index, now if I'm trying to include the current house, I have to exclude the previous house itself because I cannot take the adjacent houses. So whatever best excluding can do plus whatever is my answer 1. So can I say the current best is what? 1 itself. 0 plus 1 is 1. Right. Initially I am initializing them with 0. And what is the best I can do if I'm excluding this house? If I'm excluding this ith house, can I say that it is up to me? I can either include or exclude whatever best can be there. So what is the max of both of these two values? 0. So I will write 0 here. Okay. So those who have not understood, just bear with me again, right? Okay. So let us move forward. Okay. So now this has become previous and this has become next. This has become next. This is the current answer. This is the current house we are standing on. If I am robbing this house, I have to exclude the previous house. So 0 plus 10 is 10 is the best I can do if I'm robbing this house. And if I'm not robbing this house, the best I can do if I'm including or excluding, the best I can do, that will be coming here. So best of the previous houses is 1. Correct. Now again, these variables are updated to these values, and now this person has become the previous. This is the current house. Here I will write, if I'm trying to include house number 2, I have to exclude house number 1. So previous house is getting excluded. 1 plus the profit is 3. The best I can do from the previous house itself, right? It is the best of including or excluding because I'm excluding this house. So previous house can be excluded or can be included as well because this is getting excluded, right? So best of this is 10. Again, these variables including and excluding will be pushed forward to here only. And now look at this house number 4. If we are standing on this house number 4, what we are going to do? House number 3 is getting included. So previous has to be excluded. So 14 I am able to make if I'm including this house along with the best of previous house. Like if I'm excluding the previous house. Now if I'm excluding this house, the best I can make is 10. So of course I'll take 10 itself, right? So now these variables will be updated to this value. And now including the previous house is this 14 profit. Of course, if I'm including the third house, can you see 10 plus 4? 14 is the best I can make. And if I'm excluding the house, 10 I can make only, right? So fourth house, if I'm including this house, the best I'm doing if I'm excluding the previous house, 10 plus 20, 10 plus 10 which is 20. If I'm excluding the fourth house, the best is 14, right? Again, move forward. So include, exclude will come here. And now we are looking at this. So what we are going to do on the fifth house? Fifth house में क्या होगा यार? Here I am going to do what? If I am including fifth house, I have to exclude previous house. So 14 plus 5 is 19. And if I'm excluding this house, then 20 is the best I can do, right? So it is as simple as this. The space optimization is just two variables moving forward. And yes, 6 ke liye, it will be 20 plus 6, which will be 26. And max of the both of these is 20. So 20 will go forward. These variables will be, updated to these values. And this is the current house now. This is the current house. So if I'm including this house, of course, 21. If I'm excluding the house, max of both, which is 26 itself. And in the end, you can see I'll be returning the max of both including and excluded. Whatever best I can do will be the answer itself. Now let us take a look at how we are going to code this out, and then we'll be winding up the video itself. So we are back in the video itself, and now we are going to code the space optimized solution, public integer space opti. I'll pass the integer nums here. And for space optimized solution, I only need two variables, including and excluding. So I'll take integer including is equal to 0, integer excluding is equal to 0. For integer ith house, I less than nums dot length, I plus plus. If current house includes, right, I'll name these variables as previous include, and I'll name this variable as previous exclude. Now, if the current house is getting included, can I simply say that if I want to include the current house, nums of I would be the profit of current house plus previous exclude, sorry. Yes, if I'm including the current house, I have to exclude the previous house. Previous exclude is the best I can do. If I want to current exclude, can I say the math.max of previous include and previous exclude will come. Correct. Now, what do I have to do? Update. Now, this ith house, here I'll write this ith house will become previous for the next house. So update variables. So previous include is equal to current include, because current is now previous for the next ith house. Previous exclude is equal to current exclude. Now definitely when we move to the I plus 1th house, these previous include previous will be pointing to this. In the end, I'll be returning math.max of previous include comma previous exclude. And this is the space optimization for this problem. Let us try to call this return space opti. I'll pass nums only, and let us see if it is working. I'll not need any DP array for this. Let's see if it is working or not. So code is correct. Let's try to submit it, and then we'll wind up the video. Right. So it is working just fine. It is working as intended, space optimally. So of course, the time complexity for recursion is 2s power n. Time complexity for memoization is linear, because everyone is getting asked at most 2 times. You can see, right? This is a activity for you. You can see in the recursion diagram, everybody is getting asked only 2 times. First time when we have not calculated the answer. Second time we have already calculated the answer and we are returning only the calculated answer. So linear time for this. Tabulation is definitely linear time because of single loop. You can see directly. Space optimization is linear time, but constant space as well, right? So this was the problem of house robber. I hope you are enjoying the videos, and if you are doing so, please show some support by liking and subscribing the channel, and do comment, because if you are following this series, your comments actually, motivate me a lot whenever I read them, right? So, and I read every single one of them. So I hope you are enjoying the series. We have a long way to go. We have a long journey ahead, and I hope you are getting a hang of DP, right? We are going to solve very important problems of DP in this particular series. So I hope you will stick together. We will stay consistent. I am also trying to stay consistent by trying to upload daily, right? And let me tell you one thing, I am not a very consistent person. If I am getting consistent in something, this means that, that thing, you also can be consistent in that as well, right? So I hope that you are enjoying the videos, and see you all in the next video itself. Until the next video drops, bye.